Okay. All right. So hello, everyone. I guess we are live. I'm just going to confirm that. Hello, hello. Okay, perfect. Okay, so today I'm going to give a small workshop about Pragma, what you can build with it in the context of the Starknet Winter Hackathon. So the goal of this hackathon is to build as many cool things as you want using a lot of great technologies built on Starknet. And so Pragma is one of those. So it's I think we can get started. So I will try to share my screen. Just going to switch network to share my screen and show you a bit how, like, a high-level overview of how Pragma works. So let me share my screen. So going through the docs, so we have an extensive documentation at docs.pragma.build, which I highly recommend you go there if you're going to build with Pragma. So we're an Oracle providing any kinds of data feeds. So that's the page you would land on when going on docs.pragma.build. So starting from here, if you're familiar with the other Oracle technologies on like Ethereum, like Chainlink or PIF or all of these, so like the initial idea, I would say, is similar. So it's an Oracle, so it's a way for you to get off-chain data on-chain. So if you want to access any kind of financial data, let's say the price of Bitcoin or the volatility of ETH or yeah, we'll see all the things you can build, but that's what you would need to use. So on the sending page, you have a few repos that could be very useful for you. The first one being the Pragma hack repo. So it's actually a pretty cool template. So you can just click here on use this template and start from here. If you're going to use Pragma, it will use the latest card version, like import all the dependencies you will need in your Cairo project. And yeah, so just start from here. If you're going to use Pragma, that will save you from like setting up everything. And yeah, we will go through this repo right after. But first, let me dive a bit through the documentation. So how Pragma works is pretty much like this. So we have a network of publishers, what we call publishers or data providers, like doesn't really matter how you call them, but you have this network of publishers. There's Argent, Spacechart, market makers like Skynet, Flowdesk, Fourleaf. So all of these people that agreed to like push their data on chain on our smart contract. So you can see right here. Here you can see our smart contracts. So we're deployed on mainnet for a while and also on Sepolia if you want to play on testnet. And so you can check on StarScan in events that we have data being pushed all the time on mainnet and also on testnet, of course. And yeah, so these publishers publish data from different sources. So it could be like Coinbase, Binance, Skyco, like a bunch of different sources. Each of them has a different range of sources, depending on whether they are like a first party data provider or a third party. And then we perform aggregation. So there are two layers of aggregation, both on the publisher side and then on the sources side. And at the end, you get the final data stream. So the very, very important thing to understand here is that all the aggregation actually happens on chain. And that's like very unique feature to Pragma, right? Is that the raw data points are actually, you can actually access the raw data points. And what I mean by raw data point is that, let's say we go here to the contract, we can filter by sources, for instance. Let's say you, for whatever reason, you only trust what comes from DeFi Llama, because maybe like, yeah, that's the only source you really trust. Then um, you could specify that you only want the aggregation to happen on this source. So here, let me actually put this. Okay. So I think it's a bug of the Explorer. Let me just go on Starkscan. All right. So testnet.starkscan.com, I think. No, what is it already? Okay. So here on Starkscan, you go on Sepolia. Okay. Oh. Okay, never mind. We'll just open it here. Okay, so here you go in read-write contract. So you have a bunch of different functions to actually like read the data. So you can get the decimals, you can get the median. If so, you can specify how you want the data to be aggregated. That's also like very powerful. If you were used to other Oracle technologies that just like give you one final data point, like the price of Bitcoin, where you're like, okay, how has this been actually computed? Whereas here you really have access to the raw data. And so let's say you want the price of, let's look at the raw data of ETH USD, for instance. So 0 means spot data. And the second number here means ETH USD. So it's actually just the felt encoded string. For this, I'm using a cool plugin on Raycast to convert, but you could also use like Caro utils or like anything that converts your strings to numbers, and Caro like does it for you. So if you're doing it inside a smart contract, you don't have to do it. And so where were we? We're reading at the contract. So get data entries. So here, when you try to get all the entries for ETH USD, you can see there are a bunch of entries. Like you have an entry from Bitstamp, from Specs, from Coinbase, from DeFi Llama, from different publishers as well, because this is published by us. This is published by Space Shard. You also have data published by 4Leaf. Yeah, so you have access to all the raw data, and that's very important to understand, is that you can do much, much more than what you were used to do with other oracles. Let's say you want to like replicate what you had before and just get the price of Bitcoin or the price of Ether, then you just go like this, and boom, you only have one entry, which is the median, the aggregated median of all these entries. So of all of this, we take the median by aggregating first by publishers and then by sources, right? So here we can see the number of sources aggregated is actually 9. And the decimals is 8. And you also have the last updated timestamp, but we'll see all of this in code. Okay. You also have a bunch of other function, and let's dive into it. So here in the documentation, I highly recommend, if you're not familiar with all of this yet, to go through the documentation. We've tried our best to like explain everything as easy as possible. We even have a complete walkthrough on how to get started with Pragma, so you can just follow this. We have a Scarb library called PragmaLib that you can import in your Scarb project. Then you can also directly play with everything in Remix. That's a pretty cool feature is that Remix is compatible with Starknet for the one who didn't know. I personally had started like my blockchain journey by playing with Remix, and I think it's a very great tool for anyone to play with. So you can go here. I think you just have to install the Starknet plugin in Remix. So you activate it. Okay, it's activated. You can compile this file, which is like the quick start, which is very simple contract that just reads the data. Just reads the data from a given pair ID. So while it compiles, we will go through the features that we support. So first in documentation, here you have all the different functions. So as I say, you can filter by source. You can also do what we call hopping. So by hopping, we mean, let's say we only push like make available pairs like Bitcoin USD or ETH USD or like Sol USD. But let's say you want the Bitcoin ETH data feed, right? That's not something that our data providers push directly, but as you can imagine, it's very easy to do that rebasing. Instead of doing it yourself and like adding some more error possibility in your contract, we already provide you with this function. So you just use get data with USD hop. You put Bitcoin, ETH, the aggregation mode, and so expiration timestamp is in case you're dealing with futures data, which we also support. Like we don't only support spot data, but also futures data with different expiration timestamps. That's pretty cool if you want to do more complicated stuff. So you can use this in that case. You can filter by sources and you can get checkpoints, but I will explain that very soon. So, okay, it managed to compile. So here you can declare the contracts. Okay, so it's declaring, I think. You have to specify a provider. Actually, you can directly, I think, connect your ArgentX wallet in here. I haven't tried that yet. But yeah, I think you can. And then you can declare the contract. Okay, well, you I won't do it right now, but you have everything in the documentation in the getting started section. Okay, so if you want the list of supported assets, it's also here in the docs. Right now, we only support these assets, but if you need like any different asset, we're very happy to provide you with this one. We're just adding depending on our clients' needs, which right now are pretty much all the DeFi protocols on Starknet, but much more will be added soon. Same as for the frequency of updates is going to get increased very, very soon. Okay, so here you have the list of assets. Okay, and so let's dive into one of the, I personally think one of the coolest feature of all of this. These are called computational feeds. So it's a very fancy name to only say that because you have access to all this raw data on chain, that you can do a very complex computation on top of this raw data without like adding more trust assumptions. Like historically, if you wanted to compute the volatility of Bitcoin, you would probably have to do it off chain and like find some mitigated way, like find some way to put it on chain, but you would have a lot of trust assumptions regarding to this. And but with this, and thanks to the computation power that Starknet brings you, right? With Starknet, you can do much more computation than you could do on any like over EVM network, thanks to Cairo especially. We can do complex computation like volatility, like realized volatility, we can do it in Cairo itself and not add any trust vector in our DeFi protocol. That's the same thing for TWAP. We can do it fully on chain and not, and not add any vectors of trust in our system. And I think that's very, very important to take into account. So let me do a small demo of how these work before diving into the code. I think it's in stable here. Okay. So here you have the what we call the summary stats contract. It's just a contract where we put a lot of these data feeds, of this computational feed, I mean. So let's take, for instance, the TWAP data feed. So we have first the data type. Again, the first number is for 0, would be 1 for future, for spot, I mean. The second number is ETH USD. Then we have the aggregation mode, 0 for median, 1 for mean. And soon we will have exponential moving average, MACD, volume, VWAP. So like, yeah, stay tuned for this, but right now we will put median. Then we have the time. So let's say we want like a 1 week TWAP, put like 1 week behind. All right. It's here. And I mean, the start time is this one, and the time we can put the current timestamp. So this one. So again, it might be the Explorer is not like the best way to interact with the contracts right now. Okay, well, I guess we will directly dive into the contracts. Yeah, because the Explorer might be still a little buggy for this kind of things. Maybe it works with the mean. Let's try it out. Same thing, so you specify the data type, so the pair that you want, the start, which could be like 1 week ago, for instance, the stop, which could be right now. Then we have the aggregation mode. Yeah, same issue. Yeah, I hope they'll be able to fix that. Okay, so maybe let's try with Voyager, but I think you get the idea. So let's look at how everything looks in code. Okay, so I don't have access to like questions or anything since I am on Zoom, so I cannot see any chat, unfortunately, but I hope my explanations are clear enough. Again, if you have any questions, feel free to hit me up on Telegram, ask questions on Discord, or yeah, whoever you feel comfortable with, and I will try my best to answer. Okay, so this is the Pragma hack repository that I showed you before, that you can find on GitHub. And it looks like this. So you just need the address of the Oracle or the summary stats address. And then we have this very simple function to like check that the price of ETH is above a certain threshold. So you call the get data median on your Oracle dispatcher, which you declare here using the BI dispatcher. You call the Oracle contract, and here you will get the median. And now with the example we showed before, let's say you only want to, you only care about like DeFi Llama and Coinbase as sources, and you don't trust the other sources. We could also add Skynet, for instance, here. Yeah, hey, I only trust Skynet trading as a source. Then you go here, you put it in your array of sources, and you call the get data for the sources. Okay, very, very simple. No need to get more complicated than that. Then, of course, you might want to get the decimals to like perform the rebasing. And yeah, that's pretty much it. You can compute your threshold and return that. Okay, and here didn't mention, but the price is I mean the pair ID is just the string, which will automatically be filled and coded by Cairo itself. Now let's say that you would want to like call get the future data, which will also provide. Then you will just go like this, for dispatcher, get data median, get data median. So data type, future entry. So if USD, okay. So if USD, then in future entry, we also have a second parameter, which is the expiration timestamp. So for perpetual contracts, so future contracts that never expire, you can just put 0. Let's say you want to be very precise about the future contracts you care about, then you can specify the expiration timestamp here. Right now, we support future data from Bybit and Coinbase contracts, OKX as well. If you need different future contracts, please let us know. Okay, so get data median, future entry. Okay, so you have to put it as a tuple right there. Okay, and there you go. You have your future data. Again, for every response, we give you the price, the decimals, we give you the last updated timestamp. So I highly recommend you do some kind of check, like current timestamp is equal to the get block timestamp, and then you assert that the latest updated timestamp is like greater, or I mean not greater, but like yeah, greater or equal to current timestamp minus, let's say 500. So like you just put a certain range there to make sure this timestamp is not too old, right? And here you just put data is too old. Okay. Yeah, and that's how you do it. You could also do different checks. Let's say the number of, let's say you want to make sure there are only a certain number of sources. You want to make sure like at least three sources have been aggregated before the data was returned. Then yeah, you would do pretty much this. Not enough sources. You just check that the number of sources aggregated is greater or equal to that minimum number of sources. And we actually have a DeFi protocol that is doing that internally. And I think it's yeah, very important to understand a bit like the technology that you're using, so you don't end up with false data in your contract and like, get your protocol hacked in any way. We're very happy to help and guide you through the usage. It's very flexible. As you can see, you have access to way more information than you would with over similar technologies. And yeah, I highly encourage you to like take advantage of that and not use it as as you would have with these other technologies. You also have access to the expiration timestamp, but yeah. Okay, so that's for getting the data. Now let's look at how you would use this summary stats contract we talked about before. Okay, so same thing in Cairo, you have to declare this ABI dispatcher to be able to like call a contract on chain. So you declare your dispatcher, and then you declare your key, so the asset, the start timestamp, the end timestamp, the number of samples. So the number of samples in data feeds corresponds to like kind of the precision of your data feed. So of course, the more samples you're computing the data on, the more precise it is. But to be able to compute these like complex data feeds, you need to set what we call checkpoints. So checkpoints are like a permissionless function on our contract. So if I go back here on the Explorer, you can see that we have a set checkpoints function. These are permissionless functions. By permissionless, I mean anyone can call these anytime in the day, and they will like take a snapshot of the data that you want at this specific moment. So they will say, hey, take a snapshot of the mean price of Bitcoin right now and save that into the storage. And then you're able to use these snapshots to like compute, to do any kind of computation on historical data, right? Otherwise, you wouldn't be able to read historical data. You could technically do it by using coprocessors or this kind of technologies, and that's something we're looking into for the future. But right now, as a temporary solution, checkpoints work pretty well, and we have clients like Carmine Options that are using these checkpoints. It's very easy. We can help you set up a cron job for it. We can set up a cron job on our side just to make sure like checkpoints are set whenever you need them, right? But that's because it's permissionless, it's very easy. And once you have enough checkpoints, you're able to actually compute that that data feed. So between the start and the end timestamp, you actually need a minimum amount of checkpoints to have been set, right? Otherwise, like you don't have any data to perform the computation on. And yeah, then it's very easy, just as easy as calculate volatility or calculate mean. Again, you specify the data type, the start timestamp, the end timestamp, number of samples, aggregation mode. So it could also be mean. And yeah, that's pretty much it. You have the mean, have the volatility. We also have the TWAP. So again, you would be like this. You would go Oracle dispatcher that calculate TWAP, and yeah, very simple. So calculate TWAP. Yeah, it's data type, aggregation mode, time, and start time. So here the order is a bit different than the into and start that into, right? I think that's it. Okay, and here that's how you would compute the TWAP. Again, we have a lot more computational feeds coming in the next few weeks. EMA, MSCD, VWAP. If you want, in terms of challenges for this hackathon, building computational feeds is totally something we would love to see being built. So to tackle this challenge, just think of any primitives that exist in the traditional finance world. So we already have the yield curve, but it could be yeah, any kind of primitives like around implied volatility, around Black-Scholes. I don't think has been rebuilt yet. But yeah, any kind of primitives that power market making models could be rebuilt in Cairo, right? So yeah, just think of any of these. For instance, we have a challenge around collateralized debt ratio. So that's very important when you think about it. Right now, a lot of DeFi protocols have hard-coded parameters in their protocol, and yeah, and it's definitely so. Let me show you. Okay, so here on this repo, which I think was linked in the resources for the hackathon, we have a few case studies about how these things could be built. So we have a case study around liquidity, for instance, exactly about this. So why would you want a dynamic collateralized debt ratio? Because right now these things are set manually or like updated via governance in these protocols. And that's definitely not something that scales and not something that adapts in real time to the market conditions. Whereas that would be something very important. And the thing is that right now, because these parameters are fixed and not dynamic, the end user just loses in capital efficiency, right? You cannot get the capital efficiency you would want because your underlying model just doesn't adapt to the current state of the market. And a few things that need to be taken into account are volatility, liquidity, and then you can compute the total CDR. So we've done some simulation here in Python, but you could rebuild some of these models in Cairo, and that could be like very interesting. And I highly encourage you to think about the consequences of this thing. It could be the start of a new lending primitives in terms of yield optimizers. That's also something that could be built. So if you think about all of these yield optimizers, let's say you have three sources of yield, you want to build a vault that rebalances the assets within these different pools. But how are you going to decide upon this? You could build a fully off-chain model that decides this, but that's pretty much the industry standard right now. But you could also build this fully on-chain and removing all of these trust assumptions that the other protocols have. And yeah, I think that would be more areas that are very, very cool to explore and see how it could fit in your use case, like in the in a bigger project. Yeah. I think we've covered a lot here regarding the financial aspect of things. Okay, so it's kind of too bad I cannot see your questions, but I know this will be recorded. And again, feel free to hit me up or the Taikai, or yeah, you will find some ways to contact us. And please do if you have any questions or interested to build upon Pragma. Okay, so one last thing I wanted to show was how you could build on top of the VRF. So we have a randomness. Let's say you want some randomness on your protocol, on your game, or whatever you are building. We also provide you with a VRF. And we have some examples here. In randomness, example randomness, we have this example. So fairly simple. If you want to use our VRF, we have everything again documented in our documentation. So you can just follow along the documentation, copy paste the code here, and everything should work out of the box. Basically, you just need to call a function on our contract called request random with a few parameters. The first one being the seed, so just like some number that will be used to generate the randomness. The callback address, that's your contract, because how it will work is that we will listen to the events on our contract, and then we will call the callback function on your contract. So let's see in practice how this works. So here I can see that there has been some randomness request made actually in the last hours. But how it works pretty much like this. First, we have a randomness request event emitted. Then our off-chain service listens to this and generates some randomness using the public key that is registered on-chain. Then we change the status of your request and the call. So we call submit random on your contract, right? And yeah, that's just as easy as that. The only thing you need is a callback function that has this exact signature, right? That's very important and the only thing to respect. So you need the requester address, the request ID, and the random words. This will be where your actual randomness will be fed. Yeah. You can also check that the block number, there isn't like any issue in the block number where the randomness was generated. Make sure that the color address is our contract and not some weird contract. Just make sure not anyone can submit randomness to your contract, right? And that's it. And then you can just use your randomness and do whatever you want, from coin flipping to like complex games or just fun gambling, poker, or yeah, anything that uses randomness. Very excited to see what's going to be built with this. Yeah, you also might need to send some ETH to your contract in order to cover the callback fee. Yeah, so we just need some ETH to cover the fees of calling your callback function, right? If that makes sense. Okay. So that's pretty much it. You have more details about how everything works. We also have a Python SDK that can be used to interact with our contracts and do many other things. It can also be used as a CLI to verify the randomness, meaning you just put the transaction hash and the CLI will tell you if the randomness was correctly generated. That's very important in terms of trustlessness, because that version of the VRF is not like fully trustless, meaning that we just put the proof as part of the call data, but we don't actually verify the randomness on chain. This will come in a further version of this, but it's not currently possible right now. Okay, also right now, yeah, the fees can only be paid in ETH. Soon it will also be available in Stark token. Yeah. Everything is in the documentation. So again, if you have any questions, please feel free to let me know. I'll be very happy to answer these. The last thing I wanted to talk about today was the Pragma API. That's something that we haven't talked a lot yet about, but you will see soon in the announcement that we'll do. But it's basically what we've discussed. On chain. We also are doing it as a more classic Web2 API. So if that's something you need very accurate, high frequency data. Just let us know, like, be to power your front end or your back end. Yeah, just let us know. It's also something we can provide. Okay, I think we've covered a lot of things today. Feel free to just look at all the resources that we've covered here. Make yourself comfortable and familiar with all these tools. It can look complicated at first, but it's not that hard if you're familiar with similar technologies. Like, should be fairly easy to pick up. But again, I highly recommend you to think outside the box when it comes to using Pragma, and not just be like, hey, that's great, I'm going to use Pragma to get the price of Bitcoin against USD, but I can do much more powerful things than this, right? You have access to this complex financial primitive that it wasn't possible before Starknet. Over EVM networks, you just cannot do all of this computation on chain. And I think that's something that, yeah, I hope everyone is going to keep in mind while building during this hackathon. Yeah. Okay. Okay. So I will stay available for any kind of questions. Okay. I hope you could also see the actual code, which I don't think you could. I will show it again, but I don't think you can see the code throughout this entire workshop, but the Pragma hack repo with how you can query the if threshold, specify the different sources, query the different data feeds. Again, everything is available on GitHub. You just copy paste, play with the different parameters, deploy on Sequoia, try to change something, run scout build. Yeah, we also have some examples of a lot of people that are using Pragma in their code to see how they're using it. Yeah, it's a bit sad that it wasn't available. I wasn't sharing the right screen, but well, here it is, how you can perform some checks on the data freshness. We can perform some checks on the number of sources aggregated. Yeah, I hope it was clear nevertheless. Yeah. Okay. So I guess I will stop here. Yeah, again, feel free to jump on Telegram. So my Telegram is evolve0x. If you want to DM me, feel free. I'll be able to answer any of your questions. And yeah, I guess happy hacking, think outside the box, build awesome things on Starknet, and I can't wait to see what comes out of all your gigabrains, right? Yeah, awesome. Thank you very much, everyone, and have a nice day, morning, evening, wherever you are. Thank you. Bye bye.